All right, for this problem, we're being asked to find a second derivative, as you can tell by that symbol right there. And once we find that second derivative, then we can plug in the value x equals -1 and calculate our answer. So the first thing I'm going to recommend doing for this question is actually not taking a derivative yet, but instead rewriting this function as a power function. People miss this question because 1 over x cubed, not everybody knows how to use that with the power rule, but if you wrote it as x to the -3, that's much easier to take the power rule for that derivative. Next, if I have minus 1 over x, instead of leaving it like that, why don't I write it as minus x to the -1? And then finally, plus x squared doesn't need to be rewritten. So one of the common mistakes in this problem is people think that this is the first derivative. All I've done was I rewrote the original function here as y equals. Please realize this is not a derivative. This is just the original function rewritten so that now I can use the power rule. So keep track of what function you have by stating what it equals. So this next one is going to be y prime, the first derivative. Now I'll actually use the power rule that we've learned in this chapter. So to begin, let me take that -3 and make it my new coefficient. Here's my x, and I'm going to subtract 1, giving me a -4. Next, I'm going to take this -1 and multiply it as my new coefficient, giving me a positive x to the subtract 1, and you get -2. Finally, x squared, that should be an easy one for all of us by now. That is simply 2x. So this is my first derivative, and since I'm trying to find two derivatives, I'm just going to keep going using the function as it's written. I wouldn't rewrite it at this point because it's already written perfectly for power rule. So now I'm going to take -4, multiply it in front, and that gives me a positive 12, x to the subtract 1 to the -5. Then I'm going to take this -2, bring it down in front here, giving me a -2x to the -3rd power. And finally, plus 2x, the derivative would simply be 2. Now that I've taken two derivatives, if I want to plug in this value, one thing that's really helpful now is to have this written without any negative exponents. Some people didn't know what to do when they plugged in -1 raised to the -5th power, but it's much easier if you see it as 12 over x to the +5, and then minus 2 over x cubed, finally plus 2. So writing the function that way now allows us a very easy function to use here, where now I want to plug in a -1 into this second derivative. So what do I have? I've got 12 over x to the 5th minus 2 over x cubed, finally plus 2. And there are going to be a couple of -1s being plugged into each of these x values. So in order to calculate this final answer, we just have to make sure we know what -1 is raised to different powers. So if it's raised to the 5th, that is going to give us a -1, meaning that first term is simply a -12. If we raise -1 to the 3rd power, that's also going to be a -1, giving us now a plus 2, and we still had that plus 2 to begin with. So -12 plus 2 is -10. Add 2 to that, and now we have our final answer of -8. If you want some good practice finding second derivatives and plugging in answers, please try these two questions. Notice the first one has a 1 over x as its last term. Please rewrite that before taking a derivative. And for number 2, both of those terms should be rewritten as power functions. Good luck with those second derivatives. They can get a little tricky, but please practice those. Good luck, and post in the comments.